Hi guys, this is Miss Scott, and in this video we're going to go over some of those main ideas from the chapter 10, and then these formulas you can use on the test, and it'll just be a good way to kind of review and wrap up the chapter. So first of all, a central angle and an intercepted arc are congruent. So we're going to draw a picture of each of these ideas as well. So if you go ahead and put a dot in the center and draw in that central angle, let's suppose that this is 30 degrees right here. Well, it turns out that that arc that is intercepted would also be 30 degrees. So those are always congruent. For an inscribed angle, that's what we did that poster activity in class all about. That's a little different. So an inscribed angle has half the measure of its intercepted arc. Excuse me. So if we look at an inscribed angle, so say we have this angle over here, and if this angle is 30 degrees, well then its intercepted arc is actually going to be double that. So it's going to be 60 degrees. So the inscribed angle is half the measure of that arc that it intercepts. All right, then in the very last section we talked about a couple more theorems. The first one is if you have some point outside of the circle. So go ahead and in your picture here, somewhere outside of the circle, put a point, I'm going to call it P. And if we create an angle there, so just draw some sort of angle going through the circle. It turns out that that angle is equal to half of the big arc that's created minus the measure of the little arc. So in this example, let's just throw some numbers out there. Let's suppose that this arc here, let's say that measure of that arc is 100 degrees. And then let's say this little arc that it goes through is 20 degrees. So in order to find the measure of angle P, let's say this is x degrees right here, x is going to equal half of that 100 degrees minus the 20 degrees, so that would be half of 80, and we would get 40 degrees. All right, so there's just a little example for you. Now on the other hand, if the angle we're trying to find is inside of the circle, so we'll draw two intersecting lines in your circle, so we get an angle there. So I'm going to draw this line here and this line here. All right, so let's say that this here is angle Y. So I'm going to put Y there. And then you actually do still use the two arcs that angle or those angles go through. So let's say we've got an angle here. So we're considering that angle, and we're considering this angle here. So instead of subtracting those two arcs, we actually add them. So we're going to do half of big plus little. All right, so let's suppose the bigger arc here is 30 degrees and this littler one is 20 degrees. So what we're going to do to find the measure of angle Y, we're going to take half of the big arc, which was 30 degrees, plus the 20 degree angle. And if we take half of 50, we're going to get 25 degrees. All right, so it's actually just the average of those two arcs that you have. Just kind of interesting fact. All right, let's look at our next problem here. If you have a tangent line, so remember a tangent line just touches the circle on the edge. So let's say we have this tangent line here. And then a secant line goes through the circle. So then let's say we've got the secant here. That's actually very similar to what we talked about with the inscribed angle. So a tangent and a secant give you an angle that is half the measure of the arc. So say that you want to find this angle, let's call it A. If you know that this arc here, so let's say that that arc is, I don't know, let's call it 200 degrees. So if that arc is 200 degrees, angle A would be 100 degrees. All right, so it's always half of that arc that it creates there. All right, let's look at our last idea here on the front. Inscribed quadrilateral is giving us opposite angles that are supplementary. And if you need to remind yourself that supplementary equals 180 degrees, go ahead and write that. So for example, put 4 points on your circle here. It doesn't matter where you put them. And then connect those to create a quadrilateral. And then suppose you know this angle over here is 100 degrees. Well, then this one over here has to be 80 degrees. Let's say this one here is 110 degrees. Well, then this one here would have to be 70 degrees. So the opposite angles, the ones across from each other, have to make 180. All right. Then we're going to jump into those two formulas from chapter 11. Okay, so we talked about arc length and then we talked about sector area. First of all, arc length is this formula. So remember, S is what we use to represent arc length, and then if we divide that by the entire circumference, that equals theta, which I was drawing them like this in class. Oops. Whoa. Let's try that again. So arc length over circumference is equal to theta, remember the angle, over 360 degrees. And if you want to remember, circumference can be calculated by taking 2 pi times the radius. So in your circle here, it might help to draw this out. Draw yourself a inscribed angle, and then we have theta is however many degrees they give you for that. S then is this length, so this is the S that we're referring to. It's the length of that arc. All right, so that's the S that we're trying to find. Okay, and then again, you fill in, usually we're solving for the arc length, so you fill in your circumference. Just to remind yourself, the radius to calculate that circumference is there. So you take 2 pi r, fill that in for C, fill in your angle for theta, and then you can cross multiply to solve for S. The sector area, on the other hand, do this in purple, is found by taking the area of the sector over the area of the entire circle, and then that's still equal to theta over 360. All right, so again, we've got our center. Draw yourself a sector. And then we're not finding the arc length. What we're actually doing here is figuring out the area of this sector. So it's like how many square units this area would be. So that is what you're calculating. You're calculating a part of the area. You still need to use theta, and you actually still need to use the radius, because in order to find the area of the entire circle, we need to use pi times the radius squared. All right, so again, your first step in both of these formulas is to find the circumference or to find the area, because you're going to need to use that to find that unknown. So in either of these cases, that's your first step. Then you can fill in what you know, which is usually the circumference or the area of the circle, and theta, and then cross multiply to find either the arc length or the area of the sector. All right, so in this space below, you can put any examples that you would like here. So if there's a particular example that you are a little bit worried about, go ahead and put those in that blank space. And good luck on your test that's coming up. See me if you have questions, but I appreciate you guys tuning in, and feel free to subscribe to my channel if you haven't done so already. All right, we'll see you guys next time. Take care.